This lesson is on graphing out quadratic functions when it is in this format right here, which is what you've seen this before because this is how we this is the format that we get it in to find the roots of our parabola. So remember the general form that we use is f of x equals ax squared plus bx plus c, but once I get it into this form I can figure out what the roots are of my parabola. So sometimes the equations can be written in different formats. So let's take a look at question number 1. In question number 1, you're asked to graph the function and also identify key features of the function. So what I would like to do is go through and find the key features first, and that's going to help us find the graph easily for this function. So the first thing that I want you to be aware of is that the key features that we need to find are going to be the roots, the vertex, including, and that's going to help us find the axis of symmetry, finding the y-intercept, and determining if the vertex is going to be a minimum or a maximum. So let's first of all look at this equation right here. Because it's in this format, I can easily find my roots. I just set f of x equal to 0. So I get 0 equals negative 2 times x minus 2 multiplied by x plus 7, which means that my roots are going to be positive 2 and negative 7. Okay, so these are my roots, and that's key information to help me out. So here's one key feature that I need to find in order to graph out this function. Okay, now remember that a quadratic equation is symmetrical, so I can find the root, or excuse me, I can find the axis of symmetry because it is exactly halfway between both of my roots. So what I'm going to do is I'm going to take the average of my roots and I'm going to use that to help me figure out what my axis of symmetry is. So I'm going to do 2 plus negative 7, cut that in half, so I get negative 5 over 2, which means that my axis of symmetry is going to be x equals negative 2.5. Okay, so that's my second key piece of information that's going to help me graph out my function right here. All right, the next thing that I'm going to do is I'm going to find the vertex of my parabola. All right, so I'm going to figure out what the vertex is now that I know what the axis of symmetry is. And remember, in order to do that, all I have to do is take my x value from my axis of symmetry and plug it in instead of x in my function. So basically, all I need to do is figure out what f of negative 2.5 is. Now you can do this by hand, but it's okay if you just do it right into your calculator. So remember, if you're going to do it in your calculator, all you need to do is store negative 2.5 in as x. So remember, I'm just going to type in negative 2.5 and then control store is x, press enter, and then to figure out what f of negative 2.5 is, I just plug in the equation, or the expression that f of x is set equal to. So I'm going to type in negative 2 times x minus 2 times x plus 7, and it's going to spit out my value for me. So based on this information, that means that the y part of my vertex is going to be 40.5, or f of negative 2.5 is 40.5. So I can type in right here that it's equal to 40.5, which means that my vertex, which is another key feature of my graph, is going to be negative 2.5, 40.5. Now, when I do this, though, I need to identify, is this going to be a minimum or is this going to be a maximum? And in order to find out the information, it all boils down to my a value. Now, if you notice right here, it still says that it is an a value. So this a is the same thing as this a right here. So that means that this a value is negative, which means that it is going to open down. It's going to be a sad face, which means that this vertex is a maximum, and that's key information as well. Okay, and lastly, the last piece of information that's going to be helpful is my y-intercept. Now remember, the y-intercept is easy to find when it's in this format because it's just the c value. So I'm going to put it in that format right here. So I'm going to take f of negative 6, or sorry, f of x, and I'm going to figure out what it really is. So f of x is equal to negative 2 times x minus 2 times x plus 7. And then I'm just going to go ahead and distribute the x minus 2. So when I distribute it, I end up getting f of x is equal to negative 2 times x squared plus 7x minus 2x minus 14. So then when you combine your like terms, you end up getting f of x equals negative 2 times x squared plus 5x minus 14, which means that f of x is equal to negative 2x squared minus 10x plus 28. This 28 right here is the y-intercept. So that means that I can indicate that the y-intercept is going to be 0, 28. Okay? So I now have all the information that I need, all the key information, in order to be able to graph out this quadratic function. So I need to set up my graph right here. So first thing I'm going to do is I'm going to look at my x values, or my roots and my x-intercepts, and my axis of symmetry. And I know it's anywhere between 2 and negative 7. So I think it would make most sense for me to graph out from negative 10 to positive 10, so I have a good view of what my graph will look like. So I will draw my my y-axis all the way. I will draw my y-axis all the way down, right down the middle. So I will have my y-axis right here. It'll look just like this, right here. Okay, and then my x-axis is going to be determined by my y values. So if I look right here, my highest y value is 40.5. The y-intercept is 28. I know the roots will intersect the right on the x-axis, so that means that y will equal 0. So I need anywhere between 0 and positive 40.5. So I'm going to make it so that my y-axis is really down here because I'm not as concerned about the lower half of my quadrant, so I'm not worried about negative y's. So then all I have to do is set up my graph so that it works for me. You're going to have to do some thinking about how you're going to set this up. First of all, do not forget to label x and y axes. And then we have to figure out what our numbers are going to be. So I know that obviously this is 0, and if I go up by 1s on my x-axis, I will get to the 2 and to the negative 7 that I need. So I'm going to go ahead and go up by 1s, but I'm just going to label every 5. 1, 2, 3, 4, 5. And then I'm going to label this right here as 10. And then down here this will be negative 10, and over here this will be negative 5. Okay, and then I'm going to do the same thing for my y-axis. I need to make sure that I get up to 40.5. So I know that if I go up by 3s, for example, or even 4s, I will make it to 40.5 easily. So what I'll do is I'll go up by 4s. So I know this is 4, this is 8, this is 12, 16. So right up here, I know that this right here is going to be 20. Okay, and then another 5 will bring me up to 40. So 1, 2, 3, 4, 5. Right up here will be 40. I know that another 5 will bring me up to 60. And then that's good for right now. Now I can go ahead and graph out my information right here. So I know that the roots are at 2 and negative 7. So I know for a fact that there's going to be a data value here, a point on my graph here, and then there's also going to be a point on my graph right here. So 2, negative 7. I know for a fact that it goes through the y-axis right at 28, so I'm going to put a 28 right here, a dot right on 28. And then I know that negative 2.5 is going to be my axis of symmetry. So I'm going to draw my axis of symmetry in right here. So, and I know it's going to happen right at negative 2.5. So I'll go ahead and draw my axis of symmetry right here so I can see it a little bit better. Let me just move it over a little bit so you can see it even better because it's not quite in the middle. So I know that my graph is going to be symmetrical around this line right here. So lastly, I just need to graph out the vertex right here. And again, I know it's a maximum, so I'll go ahead and graph it out. It's at negative 2.5 and then 40.5. So I'm just going to go slightly above the 40 mark right here. I'm going to put a dot right there. And then every graph is symmetrical. So if you look right here, it's half, 1, 2, 2.5 steps to go to this point right here, which means that I will go 2.5 steps this way. So 1/2. 1, 2, here's 2.5 steps right here, and I know it's going to be symmetrical right here, so I'm going to put a dot right there, okay? Let me fix this dot right here so you can kind of see it a little bit better. I'll put it a little bit more on the axis of symmetry, so right here, it might be a little bit easier to see. So again, half, 1, 2, and then I just line it up so that these 2 points are symmetrical with each other. Now all I have to do is connect my dots. Hopefully yours will look better than mine does since I'm doing this on the computer. Right here. Don't forget your arrows, and don't forget to label your equation. F of x equals negative 2 times x minus 2 times x plus 7, and that's how you use the key features of your graph in order to graph out your equation. All right, now I want you to look at question number, or your calculator, excuse me. I want you to take a look at your calculator, and I want you to insert a graphing page. And we're going to go ahead and graph out what the function is that we have in number 1. So it's negative 2 times x minus 2 times x plus 7. But here's the thing. When you graph it out, you can't really see the full parabola. But if you look at what we did in this problem right here, we know that it's going to go from negative 10 to positive 10 on my x-axis. And it's going to go from negative 8 to 1, 2, 3 to about 72 on your y-axis. So I can go ahead and change my window so that it looks exactly the same as my graph on my paper. So it's going to go from negative 10 to positive 10, and we went up by 1s, so that's the x scale. And then the y minimum went from negative 8 to 72, and it went up by 4s, and then I can press OK, and I can see my full graph exactly how it looks right on my paper right here. And then I can even use the trace function, so menu number 5, graph trace, and I can figure out at 0, my y-intercept is 28. I can figure out that when x is 2, so you can type 2 in for x, press enter, it'll tell you it's 2, 0, so you know for a fact that it's a root. The 2 is the root, and that 2, 0 is the x-intercept. I'm going to type in negative 7, see what I get. I end up getting negative 7, 0, which again confirms that it's a root. And then I'm going to type in negative 2.5. If I look at it, it appears to be at the vertex. I'm not 100% sure it is. I would need to use the maximum function, but I have an idea that it is the vertex. So use your graphing calculator as a tool to check to make sure that you graphed it out correctly. Now in question number 2, you have 2 options for being able to find out all this information. The first option is what we've learned in class, where you can use x equals negative b over 2a to find your axis of symmetry, or you could factor this expression, find the roots, and then use that information to help you figure out what the axis of symmetry is, because it's halfway between the 2 roots. I'm going to go that way. So what I want you to do right now is go ahead and figure out what the roots are going to be for this parabola. Press pause and then check back with me to see how you did. Alright, so the first thing you're going to do is ask yourself, is there a GCF? The answer is yes, there is a GCF. The GCF is 4. So I'm going to factor out the 4. I end up getting x squared plus 5x plus 6. Now I'm going to look for 2 numbers that multiply together to give me 6, but add up to give me 5. A lot of people will still try to use 6 and -1, but the problem with using 6 and -1 is that it multiplies out to give you -6. The only way you can get a +6 and a +5 is if they are both positive. So x plus 3 and x plus 2, which means that my roots are -3 and -2 because I'm not worried about this a value of 4 right here. So that's the first key piece of information. I know the roots, and they are -3, -2. All right, which means that the axis of symmetry is halfway between these two numbers right here, so I'm going to find the average. So I'm just going to figure out what -3 plus -2 is, cut that in half, so I end up getting -5 over 2, so I end up getting -2.5. Okay, so that means that the axis of symmetry is going to be -2.5. You could have also found that using x equals -b over 2a. So that means that the next key piece of information that I have is that x equals -2.5 is my axis of symmetry. Okay, so I have two key pieces of information, the axis of symmetry and the roots. Next thing I need to do is find out what the vertex is going to be. So I'm going to go back to my calculator page, and I'm going to store -2.5 in as x. It's just a coincidence that they both ended up having the same axis of symmetry. But this time so I don't have to store it in. This time I'm going to type in 4x squared plus 20x plus 24. And that means right here that my vertex is going to be -2, -1. So I'll write down that my vertex is just what we said. And I'm going to look at my a value, which is 4, which means that it opens up. It's a happy vertex. It's a smiley face, which means that this is going to be a minimum. The last piece of information that's going to be helpful is the y-intercept. So the y-intercept is just the c value. This is in the format ax squared plus bx plus c. So I can figure out that the y-intercept is going to be 0, 24. So now I know that my roots are going to be from -3 to -2, and that my axis of symmetry is at -2.5. So when I create my graph, I'm not really as concerned about the positive x values. Also, I have to have, sorry, I forgot my parentheses here. Also, I have to have my x value, or excuse me, my y values go from -1 to +24. So when I create my chart, my graph, I'm going to make sure that I don't really show much of the positive x values. So I'll put my y-axis right here. All right, and then I need to go from -1 to +24. So I'll just put my my x-axis right here. Don't forget to number and label your axes. So I'm going to put x right here, excuse me, and then I'm going to put y right here. And it goes from 0 right here all the way up to 24. So I think if I go by 2's, I'll be okay. So 2, 4, 6, 8, 10 right here. So I'm going to say that this is 10. And then go up again, 2, 4, 6, 8, 10. So this right here is 20. Again, 2, 4, 6, 8, 10. This right here will be 30. All right, and then I'm going to go by halves on my x-axis, so I know that every 2 is going to be a whole number or an integer. So -1, -2, -3, -4, so on and so forth. So I'm just going to label this right here as 2, -2, -4, -6, and this will be negative 8. So then I'm going to graph out where my roots are. So my roots are at negative 3, negative 2. So I'm going to go ahead and put my dots right at negative 3 and negative 2. All right. I know that the y-intercept is at 24, so I'll put a dot right here at 24. I know that from negative 2 to 0, it's 4, or excuse me, it's 2 away. So right here, I'm going to go 1, 2 away from negative 3, and I'm going to have that match up right here. So this right here is going to be my other point of symmetry that matches with this one right here. And then second to last, I'm going to draw in my line of symmetry, which is at negative 2.5. So this is right here where my line of symmetry is going to be. Okay, and then I know that the vertex is at negative 2.5, negative 1, so it's going to be right here. Okay, so then I can go ahead and connect my graph just like this. It was my my vertex was a minimum, so that worked out for me. I'm going to write the equation on my graph. G of x equals 4x squared plus 20x plus 24. And then I'm just going to do this right in my calculator just to make sure that it's okay. So let's take a look at this right here. I'm going to insert a graphs page. So 4x squared plus 20x plus 24. And then I'm going to change my window settings again. So it's going to go from, I believe we went from negative 8 to 2. And then we also went from negative 2 all the way up to about 38. Graph it out. There we go. It looks pretty good. And that is our parabola.